All right, so we're going to dive into my recorded presentation in a minute on using R with open data for your NGO or CSO, but we wanted to start with a couple of questions about your familiarity with data for analysis and statistical software, just to get an idea. So the first question up here is, does your organization use data for analysis? And it looks like many people have answered, or they're in the process of answering, and we're getting a lot of yeses. We're at 96% so far. So I'm going to say that's the winner. We'll give it a few more seconds to see, but yeah, overwhelmingly, plenty of data being used for analysis in your CSOs and NGOs. All right, and the next question we have, okay, so we ended up 84% with yes, that's great. So the next question we have is, what kind of statistical software have you ever used or do you use in your current position at your NGO, CSO? So SPSS, Stata, SAS, JASP, R, SQL, other, or none. So I only mention this because, you know, if we have a lot of people who have been using proprietary statistical software programs, my presentation on R hopefully might convince you to use a free one because it's very powerful and it costs your organization nothing. And if you haven't used any programs before, I would say, hey, start with R because it can save you guys money. All right, so it looks like with the majority, we have 51% saying none. Okay, and then after that, it's kind of split between SPSS and other. So with that in mind, we'll transition to how you can use R to analyze open data to do some descriptive statistics and produce publication quality graphics, as well as shareable reports with R Markdown and even web applications with R Shiny. All right, so Shane, we can transition. Yep. Hello, I'm Chris Inkpen with the Division of Applied Justice Research at RTI International. Today, we're going to be speaking about using open data for analysis and publication in R, an open source statistical programming language. For a brief overview of the presentation, first we will discuss what R is, data and how it can be manipulated with R, creating publication quality graphics using the R package ggplot2 and its extensions, and generating shareable static and dynamic reports using R Markdown. Lastly, we'll look at using R and Shiny to create web applications and dashboards. So first, what is R and why should your organization care about it? R is a free and publicly maintained statistical programming language that was developed nearly 2 decades ago by statisticians. Today, though, it has millions of users around the world, and its features have turned from basic statistical analysis to advanced programming functions such as web scraping, machine learning, advanced text analysis, and web application development. For basic analyses, R can be used for data collection, along with descriptive and inferential statistics, graphing, and carrying out qualitative data analysis. RStudio is a free graphical user interface that provides R with a convenient interface similar to many commercial statistical programs, such as SPSS, SAS, or Stata. This glimpse of the RStudio environment shows that R has 4 main views: a scripting or coding pane on the top left for replicable analyses, although it's important to note that R has point-and-click functionality. On the bottom left, we have the console, which allows for reporting results, errors, and all output associated with script or command. On the top right, you can see the global environment, which stores your datasets, variables, functions, and other values for your analysis. On the bottom right, lastly, we have the viewing panel, which includes installed packages, help documentation, and copies of any plots you produce. Next, we'll turn to data, surveys, research questions, and manipulating data in R. So the data we're going to be using today come from surveys. So we will take survey responses from individuals stored in a table or tabular form and produce some general aggregate descriptive statistics. So the data we are focusing on today come from the Latin American Public Opinion Project 2014 America's Barometer Survey of Belize. These data were collected across all districts from a subsampling of towns and villages And the data cover topic areas of public opinion polling, political institutions, corruption, police legitimacy, victimization, socioeconomic status, and others. But today we're just going to be focusing on one question. So this very basic research question that we're going to look at today is whether happiness varies by location, specifically whether life satisfaction varies by district. So the question on the 2014 survey was, how satisfied are you with your life? With possible answers of very satisfied, somewhat dissatisfied, very dissatisfied, or don't know, no answer. So data can be imported into R in many formats, from its own proprietary format, which is a .rds, to text and CSV files, Excel sheets, relational database connections, and other proprietary formats, such as those found in SPSS, SAS, Stata, and other packages. To answer this question in a descriptive but informative way, we can produce a cross-tabulation of our two measures of interest, satisfaction and region. Here, we can include significance testing, such as a chi-square test that allows us to determine whether or not the findings here are a result of chance or if they reflect true differences in the data. In this example, we are producing a crosstab of life satisfaction by district, and you can see there's substantial variation by district. In this slide, I've highlighted the very satisfied category, specifically in Stand Creek and Toledo, which appear to be driving the variation at the district level. On the bottom right, we have a p-value of 0, which indicates that this difference is statistically significant. It's important to keep in mind that this does not mean that people living in Stand Creek, or rather that living in Stand Creek makes you happier than living in Toledo, although it very well may, but just that there are more people in Stand Creek reporting that they are very satisfied compared to Toledo. The true cause could be something completely different or omitted from our analysis. Next, we'll follow this same example through some basic plotting functions in R that can be used to create publication quality graphics. So in R, we use different packages for different functionalities. A package or a library can be imported into your program and allow you to access functions that aren't in base R. So ggplot2 is an advanced and customizable graphing package that renders images in a variety of formats and allows for univariate and multivariate visualization. So in this example, we can see a basic histogram or distribution of the age variable, followed by a description of the age distribution by sex. And although there's not really anything too interesting about the difference, it is interesting to see that you can look at this visually to understand if there are any differences that are notable to the human eye, as opposed to just looking at the differences in the average. So moving on to our very basic research question, we can produce a univariate bar chart of the satisfaction variable on the left and see that nearly 38% of respondents indicate that they are very satisfied with their lives. However, the faceted bar chart on the right shows how this breakdown varies substantially by district. In fact, Stand Creek has a greater proportion of people claiming that they are very satisfied than any other location. In contrast, Toledo has the lowest percentage of people claiming they are very satisfied, with more people indicating that they are only somewhat satisfied. So in addition to charts, R can be used to produce maps and choropleths, which are just data displayed on a map. In this example, we can see first a very basic outline plot of Belize, leading all the way up to a plot of the responses of very satisfied in regards to life satisfaction by district. This visual cue shows the contrast between Toledo and Stand Creek once again. Lastly, R can be used to create a wide variety of charts. The ability to customize data points, axes, titles, and save graphics in nearly any format makes R ideal for producing compelling graphics using data. Next, we'll turn to R Markdown, a reporting feature that allows for interactive coding and visualizations. So R Markdown can be used to create reports that can be shared, edited, and reproduced. Markdown documents actually interact with the data and user-written commands and allow a formatted report to be produced in a Word document, PDF, or shareable HTML document that can be opened in a web browser. What makes R Markdown very good for collaboration is that you can send the data and send your Markdown document and allow users to add in their commands and run any sensitivity tests or analyses that they need to. and then produce a formatted report for clients or other users. Lastly, I want to touch briefly on using R with Shiny to develop web applications and dashboards. So Shiny is an easy-to-approach web framework that sits on top of R commands to produce visualizations that can be used in web browsers. Creating simple or advanced visualizations allow you to share analyses and can often replace long reports without needing more than basic knowledge of web development and a hankering for following online tutorials. RTI has produced several web applications using Shiny that remain in use by our clients. In this example, we create an online tool to interact with longitudinal data to produce descriptive statistics. As you can see here, this dashboard allows users to interact with the data and produce a variety of different visualizations that can be downloaded or shared easily. This allows users to dive into your data and interact with it in ways previously unavailable by reading a report or a press release. And one of the nice things about Shiny is that your data is actually selectable and you're able to subset things. So you can do more advanced analyses without having to create a 300-page report. And actually sharing the dashboard along with the report allows people to verify claims that you make. So to close, in this presentation, we wanted to cover the utility of incorporating R into your organization if you use, collect, or interact with data. The key point to take away from this presentation is that nearly all data analysis and web programming functions can be completed in R. Given that it is free, widely used, and has very extensive documentation and online tutorials, R has democratized data and the ability to make use of it substantially. If your organization has data needs, please consider using R for future analyses.